Foreach sucks, or at least I thought it was. I ran some benchmarks just to see how bad forEach, LinQ and ZLinQ can be, and we're going to go over a lot of the benchmarks here to see what's actually true. Also, Unity just released the first version of CoreCLR, so we get to compare those with CoreCLR and Mono just to see what the difference is. And it actually came as quite a shock to me, the difference that it's making with just the bare minimum tests that I've done recently. So let's go and have a look. So I've got some charts right here that we're going to go over. So I've separated a lot of these out. So you've got arrays, lists, hash sets, and dictionaries, as well as the different types of things that you can put inside them. And these are all iterated over thousands of times in order to get these kinds of data. So the difference between them is going to vary, but it gives us a good idea of their complexity that can scale depending on how potato your device is. So starting off for Windows using Unity 6.7, of which is 6.70A2, first version with just having CoreCLR in it. So this is the worst version that's ever going to exist, and it's only going to get better from here. Okay, so for Mono, 6.7. So if you're going over an array using for or forEach, it actually doesn't matter. They're exactly the same. They will compile down into a for loop regardless. So it doesn't matter for an array if you use for or forEach. However, using LinQ, you can see it's just wildly worse. That there's going to be, what, 6-ish times worse. LinQ is the only thing that's actually allocating, and that's about 0.5 megabyte just in these tests, and for all the types of structures it's going to be the same. When it comes to ZLinQ, now for those who don't know, ZLinQ is a custom package of LinQ that doesn't allocate, and it's much more performant than the standard LinQ. Exactly the same syntax, more or less. It's just much better. So across the board, that's all pretty much the same. If we're looking at value types and reference types, they're all roughly the same there, so you don't have to worry about that. The interesting thing that kind of comes in is when we actually start looking at lists. Now, lists are what 99% of people use, and most of the time you wouldn't think about using a list, using an array if you're not expecting it to change, but we're always changing stuff over time. So lists are roughly way worse around the thing. So for loops just completely smashing everything, which are all these little blue lines over here. The red lines are all our forEach, and you can see those are pretty much, they're still better than LinQ, but not by much. ZLinQ itself is actually doing much better, so there's no allocation for it, but it's still wildly better than even forEach. If we were to look at the green line, see how much lower that is. So if you do like your LinQ syntax, but you don't like the cost of it, then definitely use ZLinQ if you can. Just don't use LinQ at all. For hash sets, so everything is kind of the same. Like the differences between these isn't that different really, but forEach is still wildly better because it's not allocating. You don't require a third package, and in fact ZLinQ is actually worse in some cases. Like if you look at a lot of these classes, which are all reference types, even the struct with a reference, and a struct with a reference is just a single struct with I think it's a long and a string. That's all it has in it. It's actually way worse than a forEach. So just use a forEach whenever you can there. Avoiding any allocations as possible. Same thing with the dictionary. It's pretty much 1-to-1 up there, where LinQ and ZLinQ are pretty much identical. Nothing is really changing at all, but forEach is still going to be much better. Yeah. Okay, so now that we understand Mono, I'm going to compare this to IL2CPP, so that way we can actually see how the numbers are changing, and that we kind of know what data has been run on. Why are these moving around? Okay, cool. I'm not blocking anything. That's good. Okay, so IL2CPP. So on arrays, things do get way better. Specifically for actually all the types get way better. This is jumping between maximum of 10 and 15. So LinQ has gotten worse, and that's kind of what's skewing a lot of these results. Even for allocations, using LinQ is way worse. They're run on exactly the same iterations, everything, so it should be the same, but of course it's not. So ZLinQ is still incredibly good, but it's still not going to beat that for or forEach. We don't care which one, because a forEach becomes a for loop when it's compiled anyway. Lists are way better. So you can see how links get worse. We don't care about LinQ anymore. We know it's trash. However, things like forEach has gotten better. Even a for has gotten better, and the ZLinQ has gotten a little bit better. And yeah, LinQ is just allocating way more. When it comes to the hash sets, LinQ is actually much better now. Overall, it has kind of caught up, but the struct with a reference hasn't changed. Foreach is still pretty solid, hasn't really changed as well. Allocations have gotten worse for LinQ. Dictionaries as well, for structs they've gotten slightly worse. Everything else has gotten a little bit better, but of course ZLinQ is actually falling behind in that case. But this kind of difference between LinQ and ZLinQ is very small. I wouldn't base any decisions off that. But of course, allocations are just, don't use LinQ. It's just bad. Okay, now for what we actually want, CoreCLR, which is the very first version that Unity is releasing. So, looking at arrays again, you can see everything has gotten way better. For and forEach is just a little bit better, but it's going between 10 milliseconds max and 8. So ZLinQ has gotten worse. LinQ is still bad, but of course when it comes to struct with a reference large, struct large and a class, they're all pretty good. But yep, struct with ref still much better with ZLinQ, because if you look before, everything was pretty bad. That wasn't a for or forEach, but now struct in a large struct and even a struct with a reference is still pretty good for everything that's not LinQ. Allocations are still large. I should also say the allocations are a very rough estimate. I haven't been able to do a proper benchmark on allocations just because I don't quite know how to do that for CoreCLR. A lot of that has changed, so keep those as a rough grain of salt. I do not guess that anything will allocate except for LinQ, so just treat these as a grain of salt again. Moving on from the gibberish. So arrays have gotten way better overall. Even ZLinQ has gotten better for value types. It has gotten a bit worse for reference types. So do your best, just use structs there. Lists, what we're interested in. So at this point, it's actually gotten, this is what surprised me. So everything for and forEach are incredibly good. The same as arrays. So they're all pretty much 1 for 1, which is incredibly good. LinQ and LinQ hasn't changed. ZLinQ has gotten incredibly worse. That I don't get. Oh, has it got worse? No. It's about the same. It's just the this is at 10 milliseconds, this is at 20. So LinQ has actually gotten better, twice as fast. ZLinQ hasn't really changed. It's slightly worse, but I wouldn't say that. So LinQ is actually way better now for lists. But for and forEach, at this point, you don't even have to decide. Like, all these little tiny bumps in the graph, they're nothing. So whatever CoreCLR has done, it's greatly optimized for each loop. So you don't have to worry about this kind of difference where a Foreach is actually about 4 times worse in mono, and L2CPP is, yeah, I'd say about 3 times worse. So of course, here, like, you don't have to decide what one to use. Moving on, hash sets. So where are we going here? We are. So hash sets for each is incredibly good. Look at that. It's like it's almost doing nothing. And it's the same for dictionaries. Like the for each is, how? I thought this would be the case where my code is just wrong, and whatever I'm doing is like stripping code out. And we're going to take a look at the code in a second as well. But that is just not the case. So even ZLinQ is incredibly good for value types, but of course reference types are still incredibly bad. The for dictionaries, the large struct is incredibly bad for ZLinQ, which is one of the interesting parts. So if you do have a struct with lots of values in it, no reference types, it's actually going to be way worse. Probably doing lots of shallow copying in the background because maybe it can't use pointers or something like that. Personally, I don't know. But yeah, so that's really good to know how incredibly fast a forAch on a dictionary and hash set is now compared to mono. It does kind of look like there is something kind of going on because it goes from about 30 down to what seems like 2. Yeah, and allocations are just bad for LinQ. Don't use that. Next part of this is I wanted to look at those are good because those are run on size 1000 collection. But what I've actually done here is I have built our new graphs showing the how long things take the bigger your collection gets. So just for mono, for a list, and this is only for lists, it goes from size 8 all the way up to 256. My data does go up to, what was it, 4,000, but at that point, you know, the number's going to speak for themselves anyway, so they're not in the graph and it kind of skews the graph. So for lists, you see how the struct with a reference just gets way worse. So if you do have a struct list of a struct with a single reference in it, just turn it to a class. You're not doing any optimizations, you're actually doing the opposite. Even for a large struct, which has, I think it's eight value types in it, that's way faster. And then when it comes to a struct interface or even a class, that wasn't in the last one, but there's not that much difference anyway. Which is a reference type because it has to be boxed and put into the collection. That does get progressively worse. Way more compared to everything else. Using a for each loop, that was for a for loop. This is for a for each loop. Everything is kind of balanced overall, but of course a struct is still going to be way faster because if you're iterating over a list, it's able to interpret that and pull out the stuff that it needs. It's way smaller, way less data to play with, which is why even like the large struct there, it kind of takes the cake. And then LinQ just gets way worse. It goes way off the chart, even for the 128. So that is a really good indication of how bad LinQ is as a collection gets bigger. But I can't imagine anyone's going to have a list about 128, at least in games. And if you are, then you really should know what type of collection and data types you're worrying about. Most of the time, people are probably worrying about 16 or 32. But this is where ZLinQ is actually incredibly useful because you can see, at least for a struct with a reference, which is kind of mimicking over here, everything is way better than everything else. There's the time it takes to iterate over them and just sum something is way better. much more than I actually thought. So at least for like a large struct, that's where it starts getting worse. So the bigger your struct, the longer it's going to take to do everything. So whatever ZLinQ is doing in the background or LinQ is doing in the background, sorry, over here, that's where things just get more complex. So avoid doing that if you can. Stop gibbering. Yeah, IL2CPP, a little bit better. In some cases, worse. In some other cases, but of course we're here for CoreCLR, of which is here. Look at that. Compared to mono, flat. The for loop on literally everything is incredibly good. The struct, I think these two over here are anomalies where I reckon it should be a bit more flat. Everything should be a bit more similar, and then it might just be my test throwing results off. Done my best to try and eliminate those as much as I can, but of course it's really hard to know. I'm not actually running real benchmark code. I'm running my own roll your own kind of stuff. Anyway, class interfaces, for loops, by far the worst, but even a struct interface is much better. So it might be that a struct interface is no longer boxed, but a class interface is. It could be the case. I don't know. And then when it comes to ForEach, like everything is still way better. The class interface, still way worse. So if you do have a list of an interface, that is going to be one of your downfalls. A list of an interface where the data type is a struct. That's much better. LinQ, again, terrible. Didn't use it, especially for large collections. The difference between this and this, or this and this, like, they may not look like much right now, but if you're running this 30 times in a single frame, your FPS is going to jump from about 50 to 40. Like, that's the difference that can easily make. And then when you're using ZLinQ, like, it's still not great. Better than LinQ. But the value types are just incredibly better. Like, look at that. Look how flat those are. So even up here for the 0.25, like ZLinQ is actually better than a ForEach loop. Is it? No, it's worse. Sorry. I talked too quickly there. Everything overall is just way worse for here. So whatever CoreCLR is doing for each loops is actually way better than some of these other like helpful stuff. So you don't have to start trying to use any fancy packages and whatnot. Just use a ForEach loop and do your thing. I know it's easier writing LinQ. I use them sometimes. It still makes me throw up when I write it. But you got to do what you got to do and profile to make sure things are okay. I did do a comparison between 22, 6003 and 6007 on Android. That is off my Samsung Galaxy S22. So it is... Sorry, that was upside down. It is a little bit old, but it's not considered a potato at all. What kind of came up here, because this is all IL2CPP, you can't build CoreCLR on Android, but what we can kind of see is between 6000.3 and 6000.7, ZLinQ is a little bit better. LinQ is kind of fine for arrays when it comes to lists. Kind of the same, like for and ForEach don't change. For hash sets, things actually get a bit better, but again, it's not that different. Dictionaries, so it's 50 max, and then that's 80 max. So everything's kind of hovering around the 40 there, and then over here it's still around 40. So nothing has changed for IL2CPP really. It looks different, but again, these are all marginal. And then if you want to check 2022 to 6.3, again, not much has changed. A little bit has changed just for loops, but that's it. So, TLDR, huge improvements from CoreCLR, at least just on using a loop, where Foreach is incredibly good. I'm going to go over the code just to try and understand why Foreach is incredibly powerful for hash set in a dictionary, because originally I thought I'd have to do a lot of shenanigans before, but it's just not the case. But we have gone from C# 9 up to C# 14. So that's a lot of improvements we've missed out on. Right, gonna have a look at the benchmark project so that we can have a look and see how things are actually set up. So this is all the actual thing is. When I run the benchmark through PowerShell, it's going to run up Unity, it's going to run the scene, which will run through all the benchmarks, spit them out to CSVs, and then close. That's all it does. And the benchmarks for the different types are all their own scripts, so that way they are able to warm up, run through JIT, get rid of any of those little lags that you'd see, and then actually iterate through each of them. Those will be through different collection types or the lists sizes that I mentioned before. So it'll be 2000 multiplied by however many collection sizes I have, which I think is 8. As for the code, what we got is, so there's quite a lot in here. Let's do that. Yeah, so I got a bunch of other tests in here as well that I will also be creating videos on, because I've been pottering around with a lot of things. You don't care. So for each of the different collections, we have all individual tests for each of them. These are all generated, so I don't manually make these, but they're all nicely set up, and then they're all actually defining their own types. So the struct that I mentioned before is literally just one property, which is a backing field, so it just becomes one float large struct. There's a whole bunch of different longs plus the one getter, along with the class is exactly the same as a struct, and the large class as well is the same. And then we've got the interface, which is the same as a class with the thing, same with the struct interface. The struct with a reference is literally just a string, and all that it's doing is it's just taking an int and saying toString, of which I believe that is its size. It'll be a very small string, but it will vary per collection size. And then, of course, a class with a ref is, we didn't see any difference there, so it's just with the string. And then a record, because those are a thing that I always forget about. TLDR, it's a class which has a whole bunch of extra stuff defined in it. If I were to do this, we can actually have a look at what it is. Yes, here it is. So this is the actual test record class. You can see how it has a whole bunch of extra stuff. There's that property that I defined, and then it defines the toString. A print members, I didn't know that existed, equality, hash set equals, and a whole bunch of other stuff as well. So it's got a whole bunch of extra methods in there, but overall it's just a class that just makes it easier to pass around data anyway. And then there is a record struct, one of those, which is the same thing, but it's a struct. That's in later version of Unity. Oh, C#, sorry. Anyway, for the tests, what we got, I'm not going to go through everything because they're all pretty much the same. So just doing a standard for goes over the array itself and just calls the property to count up that number, and then we pass it through. And the reason why we're doing that is that way we don't want the project to actually compile out any code to say it doesn't have to run any of this code, and we'd be like, structs are fast, but it's actually just stripping it out. That's why it's fast. But in this case, we're actually using the struct and something from it The reason why it's a property, not a field, is because I wanted to compare it against the interface, and you couldn't have a field on an interface. I don't know about later versions, but before you could not. So that's just where it ended up. And all of these types are exactly the same for the fors. I did do a cached version of a for loop, so you cache the size, do exactly the same thing. I did the same thing for a reverse loop as well. I just haven't put it anywhere because the data, at least when I had a look at it, didn't make a difference, nowhere near compared to the data type. That surprised me as well. So if you're big on saying, I'm going to optimize by caching the size of the thing, you're not doing anything. I'm sorry to tell you that. Destroyed it for me too. Foreach, yep, it's exactly the same thing as the for loop. So we're literally just calling the thing on a Foreach and doing that for every single type. I did do spans as well for arrays, but they didn't really change anything, so I didn't include it anywhere. It is in the data, but I will probably do this on lists and anything else I can put my hand on if there's enough interest in this. LinQ as well. So LinQ is just doing a select and a sum. This is the best case scenario for LinQ, because majority of the time you might be doing something along the lines of plus data.count length, where this anonymous class is no longer static. Because if I did do something like that, which is available, I think 2022, Unity 2022, this means that you can't reference anything outside of the anonymous class, like data.length. Then I won't let you do it because this is static. But what if I take that out? Then suddenly this is actually compiled into something else, which is what actually makes LinQ. One of the things that makes LinQ incredibly bad is just by the amount of stuff that it does actually do behind the scenes. Like, look at this big line here. This is just for a single LinQ query, really long. TLDR, it makes a static class which has the method in it and then calls in it. But if you are not making it static, like it's not static. In this case, this one is not static because you see I can't actually, it's giving me a red error. Then what that's actually doing is it's creating this every time this method is invoked. The reason why it's not working here is because I haven't compiled the game, open Unity and set it to compile. So this is best case scenario, and it's still causing the worst results in all of our charts that we saw. So take that out as well, so I don't have to regenerate everything. And then, of course, I did attempt to do a cached version as well, which is where, we're talking about making it static, and I was trying to avoid that allocation every time this method is called, but it didn't make a difference. It was exactly the same. It would make a difference if, for whatever reason, this had to be run multiple times in one method, then we could cache it. That would avoid some allocations. I'm not going to bother forEaches. We've seen already wildly better. So ZLinQ, exactly the same as LinQ. The only difference is we're running this as value enumerable, which is from ZLinQ. That just takes the data and says, I'm going to turn this into an enumerable, but it's a value type, so it doesn't have to allocate. Still call the same methods, which are all ZLinQ methods. They're just named exactly the same as LinQ. And that ends up being way better. And likewise, I did a cached version, which it didn't make a difference either. So there's a lot of stuff that I just didn't include. And then, of course, list is exactly the same as arrays, pretty much copy paste. It's just using a list instead of a array. Hash sets, pretty much the same, just no for loop, and it's just doing a whole bunch of stuff, but thankfully it's able to pass in the actual size. Oh wait, no, sorry, this is creating the data. We don't care about that. They've all got their own things there, and then the Foreach. Yeah, it's a Foreach. LinQ is still doing the same things. It's still just doing the sum, and then doing some cache stuff to see if that made a difference. And some of those I didn't actually check the cached version to see if it worked, but I'm just going to assume it doesn't make a difference because it's already cached anyway. Dictionaries, so the way that these were actually created is, and I should have mentioned this before, the key of the dictionary is the value type we care about, and then the value is it's just an int. It's always an int because I wanted it to be as quick as possible and not throw off the results. And majority of the time when you're using a dictionary, at least in my cases, you're iterating over a whole dictionary, or you're trying to do .contains in a dictionary, or a try get, something like that. Those are all going to be using the key anyway, so I didn't care about the value. And a lot of these are, again, exactly the same as before, just a forEach over the whole data to try and pull out all the information that we need. Same with ZLinQ, exactly the same, LinQ, sorry, and ZLinQ, all exactly the same as what you just saw. This is the same code for every Unity version, platform, and whatnot. The packages are all exactly the same. I don't believe those are ever actually changed. I did have hot reload in here, but it's not going to make much of a difference. But yeah, there's all the packages as well. So if there's anything that seems off, just let me know, because I'm interested in finding better ways to benchmark the game to see how things actually work and how we can make Unity faster and better, even though we could just use entities. So, that's me signing off. You have a good one, and be sure to profile.